In this video, we're going to learn how we can take circuits that have multiple resistors that are either in series or in parallel and combine them down to a single resistor. So for the series situation is whenever you have a circuit and you have two resistors that are in series with each other, and let's call them R1 and R2, you can replace them with a single resistor whose value is going to be R1 plus R2. That's a rule you probably learned in physics class. I'm just reminding you. When you have two resistors that are in parallel, you can also replace them with a single resistor. However, the formula for this is R1 times R2 over R1 plus R2. It's a little bit more involved there, but you are still able to replace two resistors down to one. Now this process will also work if you have more than two resistors. So R1, R2, and then keep going, and we'll call the last one Rn. And that can be replaced with a single resistor whose value is the sum of all these. Just add them all up. Similarly, if you have a bunch of parallel resistors, you can also do this. And when you combine them together, this one again, the formula is a little trickier. It's the reciprocal of the sum of the reciprocals. It simplifies nicely when you just have two of them to the R1 times R2 over R1 plus R2. You could do something like that here for this one for n of them, but it doesn't really work out that nice. So we say we can replace these things, but what do we really mean by drawing an equivalent circuit? What does this even tell us? And so let me go ahead and give an example here. Let's say I have a source here, and let's say it's a 10-volt source, and I have a 2 ohm resistor and a 3 ohm resistor. Now, as I said, these are in series, so I could go ahead and replace them with a single resistor that was 5 ohms. And once I do that, I can go ahead and find out what my current is here. By Ohm's law, I is going to be 10 volts over 5 ohms, or 2 amps. And I go ahead and figure out the current. Now here's the thing. If you were going to go out and actually build these circuits, if you build the circuit on the left with the 2 ohm and the 3 ohm resistors, it is not the exact same circuit as the one on the right with a 5 ohm resistor. One has two resistors, one has one. Therefore, they're not the exact same circuit. However, if you take the part where you're replacing here and put a little box, and do the same thing where after it's been replaced, then anyone outside the box will never be able to tell a difference between these two circuits. So you can measure the total voltage is 10 volts, you can measure the current is 2 amps. Whatever measurements you take outside that red box, you're always going to get the same answer. So again, equivalent circuits means that if you replace one part with a different part, then anyone else in the world outside of that would never be able to tell a difference between those two situations. That's an equivalent circuit. However, if you have someone that is inside that box, for example, let's say you had hooked up a voltmeter inside of here, then that voltmeter would have a reading here. It would have a reading of 6 volts. But over here, you couldn't do that. There is no place to put that voltmeter in the middle. And so equivalent circuits are great in that you can help simplify circuits down and solve them. But I want you to realize that equivalent does not mean equal. They're not the exact same thing. And so when you're trying to find out something inside of that part of that circuit, you might not want to do equivalent circuit because it might lose the information you're trying to find on the inside of that. Specifically, we will have problems later on where you'll have some sort of a circuit here, and I will specifically ask you find out what this voltage V2 is over here. And if you go ahead and combine those two resistors together, well, you're going to lose whatever V2 is. It's not going to exist in the circuit anymore. So equivalent circuits are great. Just realize that whenever you do equivalent circuits, you are changing things that are happening inside of that red box. It's just everything outside the red box is going to stay the same. So just keep that in mind that, again, equivalent is not the same thing as equal.